on here. Okay. You're kidding. All right. So, yeah. Y'all have no picture. Oh, you stupid machine. Here we go. Let's see. Let's try this one. There it is. Let me try this. That's not doing it. That's not doing it. All right, for those of you in Zoom, I'm trying to reset where that damn thing is showing. If it's gonna let me do it on their own. I have no idea. Yeah. Please be sure and sign in on the right date, just your initials. Yeah, I can get this. I feel like I look like one of these people who do not know what they're doing. And it's still showing too high. So that's the middle one I want. So that's too high. Let me see if this will let me do it. There we go. And we're supposed to be Zoom. There we go. Too far. And I need, oh, wrong way. Yeah. Okay. If you're online and you're in Zoom, please click the blue dots and move your mouse over my screen. Click the three blue dots and pin my screen. There's 10 people who have signed in so far. No longer have to remind y'all. Some of the classes I still have to remind y'all. And now comes the fun part where I hunt down my PowerPoint. All right. There it is. Button. Download. Open. It's not opening. Open PowerPoint. Oh, there it is. Okay. Let me see it now. Taskbar settings. I do not like my taskbar settings to have everything stacked. Close that. Nope, I need to open up a second one. Oh, I see the problem. And it's not going to let me reset my task bars. Okay. For those who came in late, there's a sign-in sheet. Please make sure you sign in under the correct date. And where did we wind up last time? Were we into the trig properties? I think we covered this slide already. We covered that slide already. Real quick. I know my technology is really. I don't always remember what I did last month. Oh. And where's the Zoom? Okay. Were we, let me see. This is. It's not freaking working. This is a slide. Okay. Did we cover this already?
I think we're studying section 6.3.
6.3, okay. All right.
We had just gone over the objectives.
We just gone over this. Okay, cool. So determining domain and range of trig functions. That's the first thing we're going to. So the domain, or well, let me see how they explain it. All right. Okay, the domain of the sine function is a set of all real numbers. So I can use any number for theta. Because I can have negative angles and I can have positive angles. And I can have angles that go around multiple times before stopping. So that's what we have. Okay. turning my computer screen so I can see it. So I can look at. One person has their camera on. Okay. So that's why the domain of sine is all real numbers. Now, the domain is the y values. I mean, the range is the y values we get here. So what are the y values we get with sine? What's the smallest y value you can get?
Here,
Not 0,
-1.
-1. And the largest y value is 1. Okay. And for secant, we'll talk about the domain of there in a moment. With cosine, again, the range is how many times can I go around the circle, both in the positive direction and negative direction? Well, like with sine, there's an infinite number of ways to do that, and so it's all real numbers. So the range of cosine and sine are all real numbers. Realizing for cosecant, secant, and cosecant, the angle can't be 0. Or a multiple of 360 or a multiple of 2 pi. Because then you can't, because that's when y is 0. Actually, a multiple of pi, I think. Yeah, it's a multiple of pi, positive or negative. An integer multiple of pi. So let me go through the next. And the domain of cosine is the same thing. So the domain of the tangent is going to be all real numbers except for the odd integer multiples of pi over 2. If we look, well, let me just draw it up here. Let's see my wonderful drawing skills without a grid. All right, so here we have the unit circle. This is pi over 2, and this is 3 pi over 2. So what they mean here by odd multiples of pi over 2, you either go to pi over 2 and 3 times it is to here, -1 times it is to here, negative 2 times it brings us over to here. So the odd multiples, you either wind up at 3 pi over 2 or 2 pi over 2, and those coordinates are 0, -1. And I left my marker there and I took their purple. That's better. So we have 0, -1, and we have 0, 1 for these two coordinates. So whenever you have tangent data and equals x, y over x, where x is not 0. Well, at pi over 2 and 3 pi over 2, x is 0. So we can't use those numbers in the domain because they give us something that does not exist. All right. Oh, second. And then for secant, yeah, we have the same thing, because with secant theta is 1/x, where x is not equal to 0. So wherever the ordered pair on the unit circle, the same points. So it's the same two angles, which is going to be the odd multiples of pi/2 or 90 degrees. I left it here. Questions on those three? Yeah. With the reciprocal trig functions, you will have places where it does not, the functions do not exist. Same thing is true with tangent, as we already discussed it. And so the only ones left is cotangent and cosecant. Well, because they are dealing with y being in the denominator, they're dealing with y being in the denominator, then it's going to be I don't know if it's odd integer. No, it's just, yeah, odd multiple integers. Let's think about this, because I think they're wrong. Oh, this is a nice reunion circle. Sorry, I'm going to have to erase it. So now we're dealing with pi and 0 radians. I'll deal with cosecant first. Is that no? They give us cotangent first. So cotangent theta is x over y, so we can't have this when y equals 0, so y can't be 0. Y is not 0 in two places. At 0 and pi. So this is wrong. It's not just the odd multiples, the odd integer multiples. It's any integer multiple. And realizing 0 is an even number. Okay, so 0 times pi is 0. 1 times pi is pi. 2 times pi is 2 pi. And if you go the negative route, you have a -1 times pi is negative pi. And then -2 times pi is -2 pi. And you still wind up in the positive direction. You go to here, and here to here. I mean, whoops, I stopped too soon. And here to here, or you're just here. This first one is just a 0 angle. And then with the negatives, you're just going in the opposite direction. So I'm still going to wind up on the same place, either at pi or 0, either at 180 degrees or 0 degrees. So they're wrong. This is a case of the editor and the author of the PowerPoint not talking to each other. I'm just assuming that they both have it right. Sometimes it's not the author of the textbook who creates these PowerPoints. Now the range for sine, we already discussed that, is the same as the sign for cosine. And it's from 0 to 0, I mean, -1 to 1 in both cases. For cosecant. And, well, for cosecant, it's either less than 1 or greater than 1. It's not gonna happen between 1 and -1 and 1. So so for cosecant, if you did this on a number line from -1 to 1, it's gonna be everything out here and everything down here. You have a gap in the middle, and it doesn't equal the endpoints. Because sine is all the numbers between -1 and +1, which, except for the endpoints, their fractions are less than 1. And when you do the reciprocals of fractions less than 1, you get a number greater than 1. So that's why we have this gap here. And the same thing is going to be true of secant. The graph of secant and cosecant, the graph of the functions, sine and cosine, those graphs are just shifted from each other. Same thing with cosecant and secant, the graphs of them look alike, except they're shifted. So cosine is a phase shift of sine, and sine is a phase shift of cosine. So if you know what a phase shift is. Star Trek borrowed that term. And I don't know if it means the same thing. Okay. And then with tangent and cotangent, the range is all real numbers. So when we start looking at functions, f of x equals, f of theta equals sine theta, and f of theta equals cosine theta. So these graphs have specific their graphs are very specific and unique. These are just shifts of each other. And secant. These two are shifts of each other. And then same thing is true of tangent. Oops. Tangent and cotangent. Okay, these are just shifted. They're just shifted either pi or half a pi. I can't remember which. I think these are shifted half a pi, and these are shifted. Oh, I think they're all shifted half pi. A little while since I looked at that specifically. Okay. So here's a handy dandy little table. You have access to this table. You have access to the PowerPoint, so you can pull this table up. And it just shows you what's going on there. Notice on sine and cosine, they're saying all real numbers from -1 to 1 inclusive. Because if they did not say that inclusive, it would not include those two numbers. And for cosecant and secant, the range is the same, but their domains are different. Yeah, notice here they have it correct, where in the slide they had it incorrect, where they said odd multiples here. It's not odd multiples, it's all integer multiples of pi, including 0. Yeah. The table was something they just copied out of the textbook. And they didn't transcribe it correctly when they wrote the slide that talked about this. And oh, sorry. A little button on here that blacks the screen out. So I hit that sometimes. And here we have. Okay. 2 pi k, where k is an integer number, any integer. Okay. All right, well, we kind of already saw this because we were asked questions like what was the sign of 17 pi over 4? Well, that was pi over 4 plus 16 pi over 4, which is pi over 4 plus 4 pi. The 16 divided by 4 is 4, and then that becomes pi over 4 plus 2 times 2 pi. So it fits this. So that means that this equals the sine of pi over 4. Can anybody tell me what that equals? So that would be this point here. What's the y value of that point?
45.
What's the cosine of pi over 4? Square root of 2 over 2. Yeah, the first quadrant angles, have those in your head. That will help you immensely. Memorizing certain things will can only help. So you don't have to rebuild the whole thing every time to understand what's going on there. Because the other quadrantial angles are based on these angles. Okay. It's just the sign's going to change. Is all. Keep putting it down. I forget where it went. Okay. And same thing is true with cosine. Periodic function and fundamental period. Function f is called periodic if there is some positive number p with a property that whenever theta is the domain of f, and so is pi plus p, and f of pi plus p equals, f of theta plus p equals f of theta. If there is a smallest such number, p, then the smallest value is called the fundamental period. So if we back up to this slide, the fundamental period here for cosine and sine is 2 pi. If you go 2 pi and then you go to that angle, no matter how many times you go around, you're still going to go to that angle. Okay. And we sometimes reference, we say that where theta is less than, is 360 or less, positive, it's a reference angle. Actually, the reference angle is in the first quadrant. And then we just account for where is it in the, which quadrant is the angle. But we'll get to that. So periodic properties. Tangent and cotangent both have a period of pi. And the other four have a period of 2 pi. Okay. So find the exact back. Well, I already did that one, didn't I? Letter A. I did that one. So cosine of 5 pi, well, 5 pi is pi plus 4 pi, which is pi plus 2 times 2 pi. So I always want to write this second number in terms of 2 pi. So that means this has to be an even number. So the 4 pi. So I have 5 pi and 2 divides 5 twice with 1 left over. And so cosine of 5 pi is the same thing as the cosine of pi. And what's the cosine of pi? I'm not forgetting you on Zoom.
Is it -1?
-1. All right. So I have 2 pins in my hand. Oh, I know that. Okay. And tangent of 5 pi over 4. Well, what's the period of tangent? What did we just show that the period of tangent was? 1 pi. 1 pi. Well, so we're talking whole number of multiples. And so 5 pi over 4 is 1 pi over 4 plus pi, because 4 pi over 4 equals pi, so it's 1 more fourth. So the tangent of 5 pi over 4 is the same as the tangent of pi over 4. What's the tangent of pi over 4? No. Oh, wait. No, it's not square. Was so tangent is x over y. I mean y over x. So that's sine over cosine. What do you know about the sine of pi over 4 and the cosine of pi over 4? They're both the same number.
Just 1.
So that's 1, yes. Yeah, they show here that it went around twice. And then it went to the angle. So that's just pi over 4. And the cosine, that ends up being the cosine, the sine of pi over 4, which is just square root 2 over 2. And the next one, we went around twice. And then we went to the angle. And so cosine over here is negative. And the cosine of 0 is 1, so the cosine of pi is negative 1. We already did that. And 5 pi over 4, well, the period was 1 pi, and then we did a quarter angle. And the tangent of this quarter angle equals the tangent of this quarter angle, which is pi over 4. So whatever tangent is up here, the tangent down here will be the same. Whatever the tangent is over here, the tangent down here will be the same. So here we have another table. And it talks about which quadrant sine, cosine, tangent, and the reciprocal functions, where are they positive and negative? So if you look at the quadrant, any quadrant, half of those will be positive, the other half will be negative. So sine and cosecant are positive in 2 quadrants and negative in the other 2. Same thing is true with cosine and secant. 2 are positive, 2 are negative, and with cotangent and tangent, we have 2 are positive and 2 are negative. Now, they have this nice chart. If you thrive on tables, this is a good table. I like this picture. I like this picture. But I do it a little different than what they do. Of course you do, Mr. Lee. So I draw the 4 quadrants. 1, 2, 3, 4. And I talk about what trig function is positive in that quadrant. Well, in the first quadrant, all of them are positive. In the second quadrant, sine is positive. Right? And if sine is positive, that means cosecant is positive. And the others are negative. So other than the first quadrant, you're only going to have a pair, a reciprocal pair of these functions will be positive, just one pair. And so down here, it's going to be tangent and cotangent. And over here, it's going to be cosine and secant, right? The x's are positive over here. So cosine will be positive. The sine is positive up here. So sine is positive in these 2. Now over here, both sine and both x and y are negative in this quadrant. So, and since tangent is y over x and cosecant is x over y, you have negative over negative, which is positive. But the cosine is going to be negative and the sine is going to be negative. Something similar is happening here. The sines are negative, but the y values are negative, so the sine will be negative, but the cosines will be positive because the x values are positive. Okay? Questions? I like this picture much better than anything they've done. Because I just talk about where is the trig function, where are the positive trig functions? Okay, so the positive is everything's positive in the first quadrant. Sine is positive in the second, tangent is positive in the third, and cosine is positive in the fourth. And their reciprocal trig functions have the same sign in those quadrants. So. I think I have these magic tricks sometimes when I just pop up with these things. Well, it's because I learned this. Okay. Now, find the quadrant. All right, sine is negative. All right, sine is less than 0. So that's these two quadrants. And cosine is positive. That's these two. Well, we're both sine is negative and cosine is positive, is this quadrant. This is an easy picture to solve that type of question. So, and I go to looking at points on the unit circle. So where is y positive, y negative, and x positive? And that's the fourth quadrant. The reciprocal identities. I've been talking about this all the time. So because we also have that sine is a reciprocal of cosecant. And cosine is a reciprocal of secant. And tangent is the reciprocal of cotangent. So those the reciprocals of each other. When doing trig identities, when solving trig identities, knowing these reciprocal relationships is extremely helpful.
Wait, can I copy that?
Theta 1 over. Oops. Cotangent theta. This is secant. Okay. Move on. And here we have quotient identities. All right, these are things we know from high school mathematics, algebra 2 and geometry, and maybe a little bit from 8th grade. I don't know if they did trig. I did any of the trig stuff in 8th grade mathematics. It's been a long time since I dealt with that. I taught 8th grade for 2 years. I've been in hell. I don't like it. Okay. So finding exact identities when sine and cosine are given. I'm trying to remember how they solved this. Because they solve things a little different than I do sometimes. But I'll go at it from my point of view. So cosecant cosecant is 1 over sine. It's the reciprocal of sine. What is the reciprocal? What do you do to find the reciprocal? You flip it. And so I'm gonna flip this. I'm not gonna do what they do, because this is what we get. Now, in mathematics, whenever you get a radical in the denominator, you want to rationalize it. That means you're going to multiply by the appropriate radical so it becomes a rational number, not irrational. And so I'm going to multiply by a fraction that equals 1. So I'll change what it looks like, not what it is. So square root of 2 times square root of 2 is 2. Gets rid of the radical downstairs. And we put the radical upstairs. 2 over 2 is 1. So I take out that and it's just square root of 2. Right? Cosine, we do the same thing. So secant is 1 over cosine, which is the reciprocal of cosine. So that's going to be 2 divided by 5 square roots of 5. It's 5 square roots of 2. So like I multiply over up here by square root of 2 over 2. I have to multiply here by the square root of 2 over 2, square root of 2. And I do that so this 2 goes, this square root of 2, the square root symbol goes away from the denominator. And we put it in the numerator. So 2 times the square root of 2. And I'm going to write this as 5 times 2 down here. And there's a reason I'm doing that, because I have a factor of 2 upstairs and a factor of 2 downstairs. Those go to 1. So I take out my 1 and I'm left with the square root of 2 fifths. Now, tangent is sine over cosine. Well, sine is the square root of 2 divided by 2. The cosine is 5 square roots of 2 over 2. I can rewrite this as 1 times, because we're always multiplying by 1 times the square root of 2 over 2, divided by 5 times the square root of 2 over 2. I just factored the 5 out of the fraction, because now I have the square root of 2 over 2 divided by the square root of 2 over 2. So I'm going to take out my 1s. And this is just 1/5. Now I'm going to go to the fact that cotangent, oops, I forgot the theta up there. Cotangent is the reciprocal of tangent. I'm going to use the reciprocal identity here, not the quotient identity, because I have what tangent is. And that's easy. What's the reciprocal of 1 over 5? That was the easiest one to do. Oh, they started with that one. They started with tangent. And got 1/5. And they didn't show you how that reduced to 1/5, which I think is a sin. But well, actually, I think they did the right thing, because that's my job to show you what happened there. Okay. And then cosecant is the reciprocal of sine. I just skipped this step and I just said, well, the reciprocal of this is this. I didn't have to write it that way. And then we rationalize the denominator. Secant is 1 over cosine. And then they rationalize its denominator. And then cotangent is a reciprocal of tangent. I just skipped this part. Went straight to the reciprocal. Oop, found it. Okay, questions?
Professor, I'm having trouble looking at the numbers in the slides. If you can hear me.
You know what? I'm not hearing you I'm not hearing y'all when y'all are talking. In the let me see if we'll do it this way. Can someone talk from Zoom?
Can you hear us?
Yeah, okay. The setting was wrong. I thought it was correct. What they tell us to do wasn't what it was set on, so.
I did have a question.
Yes,
I'm trying to look at the slides, but I don't see any numbers. They're just blank slots where the numbers are supposed to be. I put an image in the chat of what my slides look like. Like I can see where all the letters are, but as soon as
Okay.
the cosecant, that's all gone. It's
what
empty.
I'm gonna do is I'm going to save the PowerPoint as a PDF file and upload that. Okay? So that way, do you have this slide pulled up?
Yeah, I have that slide pulled up. All I can see is up to identifies to get, and then I can't see any of the cosecant, secant, or cotangent. All those are blank.
Yeah, I see it on mine too, there's no numbers.
So,
Yeah.
from the equal sign over, they're blank. Or where there would be fraction numbers, there's none.
Like everything starting from the cosecant of theta equals, like the cosecant theta is not even there. Everything from
Oh, this
then we
is,
use. Yeah, the whole all the equations are blank.
here is not there.
No.
Correct. Yeah.
Okay. Thank you for letting me know. Yeah, I'll create a PDF file of these and re-upload them in files. That's an easy thing to do. Okay. I apologize. Thank you for bringing that to my attention. I didn't realize it was doing that. Okay. And since I clicked on the Zoom, I lost my power over the PowerPoint. There we go. Okay. So this is based on the unit circle. I don't know. In the classroom, I don't think we can see this. Sine squared theta plus cosine squared theta equals 1. All right. With the unit circle, we have a circle, right? And its radius is 1. So the formula for a circle is x squared plus y squared equals r squared. And they switch the cosine and sine, so this is going to be y squared plus x squared equals r squared. R is 1, so this is going to be y squared plus x squared equals 1 squared, which is just 1. Well, y is the sine, And sine squared is sine squared theta. The x is what cosine is, and so x squared is cosine squared. So this is just the formula for the unit circle based on the angle. So I don't need to know the coordinates. All I need to know is what angle we're dealing with. All right, so off to the side here, I'm gonna work this. So we have more trig identities here to deal with. Okay. We have I'm gonna write sine squared theta plus cosine squared theta equals 1. I think they divide by sine first. If I divide each one of these, so if I divide both sides of the equal sign by sine squared theta, that means everything gets divided by sine squared theta. All right, if I divide everything by the same number, I'm not changing what the equation is saying, I'm just changing how it looks. But in this case, we're going to end up using different formula. Oh, sine, what is sine over sine? 1.
1.
So this is just 1. What's cosine over sine? I think I heard
I
it.
think it's cosecant.
Cosine theta over sine theta. That's cotangent. I think someone said it on Zoom. All right, and if I square both sides, I get cotangent squared theta. So this is cotangent squared theta. And what's 1 over sine? What's the reciprocal of sine? Cosecant. So this will be cosecant squared. And that gives us our next Pythagorean identity. Oh, they didn't divide by sine. So that was this one. What they did here, what they did to get this one, instead of dividing by sine, they divided by cosine. So I'm going to divide through by cosine squared theta. And sine over cosine is tangent, so we get the tangent squared. Cosine over cosine is 1. And then 1 over cosine is secant, so that's going to be secant squared. That's a funny looking theta. And then I got number 6 for second. And I got number 7 first. Okay. The numbering thing here is a mathematics thing, a textbook thing, is that we number the equations in the textbook. So when we refer back to that formula, we just refer to equation 5 in section 6.3. So that way we don't have to write it out again. But sometimes they get long and complicated. Okay. So these two can be derived simply from the first one. So as long as I remember the first one, I can divide by sine, and then I can divide by cosine, and that'll give me these two. Yes, you will be tested over these. I'm not going to test you on deriving these, but yeah. Now, here are the fundamental trig identities. And that's what we've gone over so far today, is the fundamental trig identities. The reciprocal functions. Okay. Well, yeah. The quotient identities, the reciprocal identities, and the Pythagorean identities. So those are the fundamental trig identities. We can do a lot with these. We can use these to solve things. Okay. So if I have an equation that has 1 in it, I can replace 1 with this. Or I can solve for 1 here and replace 1 with secant squared minus tangent squared. Or I can replace 1 with this and say it's cosecant squared, and I can solve for 1 here and do cosecant squared minus cotangent squared. It all depends upon what's in the trig identity that you're supposed to solve. So you can use these aspects to change what one side of the equation looks like to the point it ends up looking like the other side. Well, here they want you to find the exact value of the expression. Do not use the calculator. So just using the trig identities. Okay. Well, what is cosecant? That's 1 over sine, right? And secant is 1 over cosine. So I'm just looking at this part of the expression, this fraction here. So I'm going to change that fraction to something else. I'm going to change it to a single trig function. So I'll have a single trig function minus a single trig function. So when I'm dividing, I can change this to multiply by multiplying by the reciprocal of the denominator. So this is going to be 1 over sine of 40 times the cosine of 40 divided by 1. So I just flip this fraction and I multiply it. Well, that's just cosine over sine. That's a quotient identity. What does it equal? What does it equal? Cotangent. So this is the cotangent of 40 minus the cotangent of 40. What do we get? We have here a 0 pair. That means when you combine them, you get 0. Subtracting a negative is adding, subtracting is adding a negative. So we're adding cotangent of 40 degrees to the negative of the cotangent of 40 degrees. So I'm combining opposites. So that means they're a 0 pair. This means 0. This one was tricky in that you end up dividing by a fraction, so you have to end up multiplying by its reciprocal. Okay. And on this one, what's the reciprocal of this is the reciprocal. 1 over is the reciprocal of the denominator. So what's the reciprocal of cosecant? Sine. So this is just sine squared of pi over 16 plus cosine squared of pi over 16. What's cosine squared plus sine squared, or sine squared plus cosine squared? What does this equal? It's the first Pythagorean identity. What does it equal? So we're just playing with numbers, which is something I love to do. These are just puzzles. Where you take each piece and you flip it around and you do things to change it to look like something else. So I did something with this. I flipped this around and I changed it to look like something else. It's still the same thing, but now it fits in the puzzle piece, puzzle better. Because now I can combine them. And it gets me where I need to be. So here they solved it. I think they solved it the same way. Yeah. No, they didn't. Why didn't they? Oh. They turned this into a fraction where I just left it this way. And I changed this one to this, and then back to the. Anyway, you still wind up with 0. And then the next one, they did the same way I did it. You got the 1. All right. Now, I'm going to solve this one differently than they do. They deal with the fact that sine of theta equals y over r, cosine equals x over r, and tangent equals y over x, and then the reciprocal functions. Cosecant is r over y, secant is r over x, and cotangent is x over y. Now, we want to find the exact value of each of the remaining trig functions. So first thing we need to figure out is what quadrant is angle theta in. The sign is positive, right? Because we have sine of theta is 1/3, which is positive, but they're saying the cosine is negative. What? Fourth quadrant. So in the fourth quadrant, fourth quadrant. Sine is positive. So sine is positive is up here. The cosine is negative, so that's this over here. So we're dealing with this quadrant. So only sine is positive here. Sine and cosecant is positive here. The other the other 4 are negative. Right? I know what sine is. Sine is 1/3. So immediately I know what cosecant is. What is cosecant? 3. It's a reciprocal of 1/3. Now, what they did, they used this. And they say this is 1/3, so R is 3. So this is x/3. And with tangent and cotangent, you don't need to know what the radius is. So from here, we have sine squared plus cosine squared equals r squared. Sine is the y value. So that's 1. Plus cosine squared. Cosine is the x value squared. And r is 3. So we get 3 squared. So 1 plus x squared equals 9, or x squared equals 8, or x equals the square root of 8. All right, but since cosine is negative, we're going to have the negative square root of 8. Because it's telling me what the sine of x is going to be. And so I need to simplify the square root of 8, which is 2 times the square root of 2. So now this is going to be 2 square root of 2 over 3. So now I have my cosine theta equals the square root of 2 over 3. I would have done this in a similar manner, except I would have used this one. Sine squared theta plus cosine squared theta equals 1. Sine is 1/3. So we're going to square 1/3, add the cosine squared, and it's going to equal 1. So we have 1/9 plus the cosine squared of theta equals 1. Subtracting 1/9 from both sides, we get the cosine squared theta equals 8/9, right? Because 1 minus 1/9. So that's 1/9. 9/9 minus 1/9 is 8/9. Now we're going to take the square root of both sides. So the cosine of theta, since we already know it's supposed to be negative, is going to be the square root of 8/9. The square root of the denominator is 3. The square root of the numerator is the square root of 8, which simplifies to the negative 2 square roots of 2 divided by 3. I get the same number, just a different process. Although some of the process is the same. Taking the square root of a fraction tends to scare some people. So using their method, I almost always go this route. To me, it's less confusing, but. And secant is going to be the reciprocal of cosine. So secant is 3 divided by the square root of 2. It's the reciprocal of the square root of 2 over 3. Now it's going to be 3 over the square root of 2. Rationalizing the denominator, you get 3 square roots of 2 divided by 2. So now we have secant equals 3 square roots of 2 divided by 2. Now we need to find out tangent and cotangent. Right over here. Tangent is sine over cosine. Sine is 1/3. Actually, if I go back up here to what X and Y are from this one, Y is 1 and X is, what is X? 2 squared to 2/3. So tangent is X over Y, so that's going to be 1/2 squared to 2/3. Right, 1/2 squared to 2/3, which is just the reciprocal of my denominator, which is 3/2 squared to 2. Rationalizing my denominator, I get 3 squared to 2. And this becomes 2 times 2, which is 4. And so this is going to be 2 square roots of 2. No, 3 square roots of 2. Sorry. I was wanting to write it the other way. Divided by 4. If you have any questions about how I get to the final number, please don't hesitate to ask. Now, cotangent, I can either look at it, so reciprocal of y over x, so that's going to be x over y. So x over y is just the x value in this case, which is 2 square root of 2 divided by 3. That was the easy one. Yeah, and option 1, using the circle. Yeah, we use y over r. And so they built it up the same way I had done, because I did it the way they did it, and then they said y is 1. And so we have this situation, and so that becomes, they subtracted 1 from both sides and then take the square root. And since we're dealing with this quadrant over here, it's, the x value is negative, and we still have to divide by r, which is 3. So that's what they did here and got the 3. So that's how they got the cosine. And then they got the tangent next. Well, the tangent's negative is, all right. Yeah, I forgot that part. Tangent's negative, the cotangent's negative, and the secant's negative. I forgot to put this cosine being negative in them. Anyway. Cosine is 2 squared, it's just 2. Got that here. 2 squared to 2 divided by 3. All right. If you make a mistake similar to what I just did there on an exam, where you worked it out and you got the answer here, and then you rewrote it over here, and you did a transcription error, as long as you got it correct here, I would count it correct. And that's just a transcription error, because I'm about the process. The process was done correctly, and you got the correct answer. And so tangent, they got the same thing I did. Cosecant is flipping the sign. Sine was 1/3, so cosecant is going to be 3. the secant is flipping the cosine. And then rationalizing the denominator. And cotangent is the reciprocal of tangent, or the x over the y. So where did I get the 3? Why did the 3 go? Oh, cotangent. Cotangent and tangent won't have the 3 in it. Where did I get the? The x over y. 1 over the square root of 2. Or 1 over 2 times the square root of 2. Okay. Okay. So that's why there's no 3 here. Or here. Yeah, because tangent and cotangent, the radius has nothing to do with those numbers. Okay. Solve for cosine. Solving for cosine means we need to subtract sine squared from both sides. So we get cosine squared theta equals 1 minus sine squared theta. And now we take the square root of both sides. So cosine theta will equal plus or minus the square root of 1 minus sine squared theta. Boom. Please notice we have to throw in the plus or minus, because we don't know what quadrant we're talking about. So it could be positive or it could be negative. It all depends on where theta winds up. Okay, so because cosine is negative, then oh. So they're using another method here. They solve for cosine theta using the Pythagorean identity. And so they're saying cosine equals and since we're dealing with negative cosine, it's going to be the negative. So we know which sign we need to use here. And then they just replace the sine squared with 1/3 squared, which is a 1/9. So we get the negative square root of 8 over 9. And so they're just solving the same problems, just using a different trig identity to solve it. That's clever. We can get the quotient and reciprocal identities based on that. So tangent is sine over cosine, which gives us the same number for tangent. And cotangent is the reciprocal of that. And then secant is the reciprocal of cosine. And then they rationalize the denominator. And is there one more? We don't have cosecant, right? Cosecant is the reciprocal of sine. So it's a matter of finding the cosine from the sine. And so you have multiple avenues of finding it, okay? In both cases, we use the trig identity, the Pythagorean identity that cosine squared, sine squared plus cosine squared is 1. But in the first method, they use 1/3 for the sine.
So, excuse me, sir.
Yes.
Can I borrow your remote for, I don't have remote in my classroom.
Oh, yeah.
So I can-
Yeah, I didn't have it yesterday either.
so maybe that-
Yeah.
Take a start with the class.
Yeah, I'll be back. I'll be there in a few minutes to take it away from you.
I start now.
Okay. Or I'll just let him keep it. Okay. What's next? Okay. Now, finding the values of the trig functions of theta when the values is 1, okay, the quadrant is no. Given the value of one trigonomic function in the quadrant theta lies in, the exact value of each of the remaining 5 can be found in either of 2 ways. Well, I had a third way of doing it, but anyway. So using the circle of radius r. Drawing, my calculus 1 teacher always said this. Draw a picture. Pictures never prove, but they help. So if you can visualize what's going on there, it helps you understand how to solve the problem. And so that was the process they did here. R is x squared plus y squared square rooted. Or r squared is x squared plus y squared, and you go that way. Either way, you can find the other 2 values, the missing value if you have 2 of them. Okay, and then, yeah. Well, yeah. This is the stuff we went through. I don't, you'll have these slides and they can help you understand what's going on when you work a problem. And then use the appropriate identities to find the volume, or using the identities, which is I think the method I like using. So square root of 3/3, find the exact value of the remaining. So I know tangent is cosine over sine. Sine over cosine. So sine theta over cosine theta equals the square root of 3/3. So this must mean that the sine theta equals the square root of 3 and the cosine theta equals 3. So this means that 3 squared plus the square root of 3 squared equals r squared. I don't know that we need to find r. I'll get back to that in a second. Cosecant is 1 over sine. So that's going to be the square root of 3/3. Secant is 1 over cosine, or the reciprocal of cosine, which is 1/3. And cotangent is the reciprocal of tangent, which is 3 divided by the square root of 3, which winds up being the square root of 3. So we don't even need to find out what r is. But this is 9 plus 3, which equals r squared. So 12 equals r squared. So the square root of 12, and since we're dealing with distance, it's positive, so I don't need the plus or minus here. And this is going gonna be 2 square roots of 3, is what R is. Now, I don't know if they're gonna throw that in there. And so I'm gonna have to divide these, multiply each one of these by 1/2 square roots of 3. But let's see what they say. All right. Oh, yeah. Tangent is positive, but sine is negative. So that means cotangent and tangent are positive, and the others are going to be negative. So I had to consider that situation, that those are all negative. The sine, cosine, cosecant, and secant are negative, where the cotangent and tangent are positive. And I get that from the fact that sine is negative and tangent is positive. Sine is negative down here, and tangent is positive here. So the angle is down here somewhere. So there they have it there. So X is 3. Y is square root of 3. And okay, so yeah, they're gonna deal with and they're gonna find R. And so this is gonna be divided by what did I say R was? 2 square roots of 3. So this is going to be a -1/2. And this is going to be divided by the 2 square roots of 3, which ends up being a -1/2. Is that right? No, 3/2. And so two square roots of 3 down here. So that's going to be 1/6. Oh. And 1/2 square roots of 3, which is square root of 3/2 negative. Doing those very quickly in my head, I'm not so sure about the answers. That's going to be negative. Yeah, so yeah, they're going to divide by R. So we get those 3 numbers. And so sine they got is -1/2, which is what I got here. And cosine is -3 over square root of 2/2. Square root of 2, 2 times square root of 3, which ends up being a -3/2. Oh, square root of 3/2. Sorry, I'm multiplying it by the square root of 3. I forgot. Okay. And then we just do the reciprocal of those. So that means cosecant's going to be different. Cosecant than what I have here. So it's the reciprocal of this, which is a -2 over the square root of 3, which is a -2 square root of 3/3. And yeah, no, cosecant. So the square, that's just going to be -2. Yeah, cosecant winds up being -2. Because that's that's gonna equal a negative 2 square roots of 3 over the square root of 3, which is, oh, wait a minute. Cosecant is the reciprocal of negative 1/2, which is a negative 2, which is what they got here. Okay. And secant is the reciprocal of the cosine, which gives us the square root of 2 square roots of 3 over 3. And all they did was pull the negative sign off front. And then cotangent's the reciprocal of tangent, which ends up giving us the square root of 3. Uh-oh. Why did that go away? PowerPoint just closed on me for some bizarre reason. Well, we're at the end of class, so any questions, any thoughts, any whatever? So y'all are free to go, and if
Are you
you're
gonna
on-
post the new slides right after class?
yeah, I'll do that right now.
Yeah, so I can find them.
No, I want to read all of it. I want to see.
No. Is it up there?
Yes.
Oh,
Oh, yeah, yeah. Sign-in sheet, please be sure you sign by, in the right column. Let's see. Yes, sir.
You're a Chelsea fan?
Hmm?
You're a Chelsea fan? You're a fan of Chelsea? The Blues?
Yes. Oh, you're Man U?
Yeah.
Go away. No, my son is a huge Chelsea fan, and because of that, I'm a Chelsea fan. I don't follow it, my son
have you
does.
been able to log into?
He knows the names of all the players in the Premier League,
Yeah.
so
Yeah.
he follows
Is
it
that
religiously.
really good access code?
When they live broadcast on Saturdays, he's watching the game,
So you can actually post
I watch it too.
so, yeah.
tests.
Yeah.
Yeah.
Yeah, I'm a big United fan.
Sounds so good.
Hmm?
I'm a big United fan.
Yeah, I got
Yeah,
that.
so, I was like, yeah.
I'm glad you got the humor of that email.
Dude, and oh, it was you? 'Cause
Yeah.
I
I
responded, I was like, have you figured it out?
Yeah.
Right.
I was wondering, I was like,
No, yeah.
I have to go to, that's why I got here late, because I was wondering like how to get here. I was like,
Yeah. So, Professor, I'm actually supposed to be in your Zoom class.
Oh.
I accidentally came today. Yeah, because I did exactly what you told me not to do. I looked in Canvas and not Aces.
Okay.
About this section.
However you want to do it, if you want to come here,
Okay,
if that's okay for you to come
Yep.
here, then do it, and I'll just,
okay.
did you write your name?
Yeah, I
down?
wrote it down.
Okay, and I'll just. You'll see a new.
yeah, I got
because
so
I have
worried.
to change that anyway, because I got the wrong dates on it.
Thank you so much.
Oh,
Okay.
and I needed my access code because it's not letting me in. Like, for my math lab,
All right, so I sent you a code.
I don't think so.
Okay, have you gotten in?
No, I mean, I tried to log in, but like whenever I try,
All right,
yes,
do you have your computer with you? or-
I have my phone.
Yeah, go ahead, pull it up.
This is so hard. I'm so confused. It's been a while since I haven't used my head.
Yeah, pre-cal, the problem with pre-cal is just, here's mathematics going this way, and here's pre-cal over here. And as mathematics is going down, it's pulling in
Yes,
the
that's right.
pre-calculus
Oh.
stuff. And so there's no,
Like in the middle. So I go to math and then. From here. Is that my math and my Latin mastering?
Yeah.
Is that one?
and click to enter. And then it's gonna ask you, you're gonna have to, once you get in there. No, yeah, that's where you click.
I
Yeah,
know.
it'll eventually go in.
Oh.
You just have to be patient with it.
Okay. I don't even know how to get like the hang of it. Because for example, like algebra last year, no, wait, like 2 years ago, like in high school, it was easier. For now, like, am I even gonna get it?
So did you take pre-cal in high school?
Yes, I think I did. Yes, I did.
So.
I had a good grade. Like it's just that I tend to like memorize stuff, you know, and like that goes away. I kind of remember this, and I remember like all the papers they gave us, and like using those, I would always like help myself like the assignments. No, that I mean.
Man, Zoom is messing up big time on me, so I'm gonna go ahead and close this down. I don't know what the problem with Zoom is.
Should I just like review?
Um,
I can't.
Before I go, Professor, what slide numbers were we doing today? What pages, I mean? So I can see if they came in.
oh,
Oh, did you already post the
no,
reposted the PowerPoint?
I'm in the process of doing that. We're on, what slide are we on?
Yeah.
93 has the fundamental identities on it.
I can't see 93. Is the bottom page number? It would be what I can see. Is it 324 or?
No, the slide number is what that we ended on. Let me see what the slide number that we ended on was. 107. Yeah, I'll go with 107. Because PowerPoint just did a belly up on me for some bizarre reason. And Zoom is really freaking out on me. I don't know what the problem with Zoom is.
Yeah.
Yeah, Zoom's not even showing me anything. It did it to me yesterday as well. I don't know, in my afternoon class yesterday. So I may have to, it could be tomorrow before I'm able to do this. I don't know why it's doing this to me.
But like you emailed me back. I mean, like a number. This is what you told me. Find here if it tells you about temporary access and get that.
Yeah, so what you were trying to do is get in there. You get in there, you create your account, and then ask you to to pay for it or use access code.
Yeah,
Use the access code, click that button to get in, and then it'll have you to type in put in the access code. Well, you don't have one, so you, down at the bottom, it says get temporary access.
oh, okay,
You click that button
okay,
and that'll get you in.
okay,
Or well, take care. Have a great day, Professor.
And then I can get the access code.
all right,
But you have to be in it before I can get you the temporary access code.
okay,
And if anybody's still in Zoom, this computer is going batshit crazy on me. So I'm not gonna be able to do it, and I've got a class in 10 minutes that I have to get to. So, either right before noon, I'll get it in there, or after around 2 o'clock, I'll get it in there. So those are, so. Okay. All right,
and if I log in today, what were the two, I remember you said that we have 2 assignments to get done. Do you remember what it was?
oh, the assignments,
Yes.
they're in
Just
my
like the
lab,
first 2 or,
they're all in my lab,
okay,
and they're all open,
so we can just work on it,
right, they'll never close.
okay.
A due date may pass, but you can still get into
work
it.
it, Okay, all right, well, thank you, sir.
Oh, man. What the hell is wrong with this computer? It's not letting me close anything. Let me pull up the task manager. It's not letting me pull up the task manager. Well, I'm gonna have to restart the computer because it's